This video is about percentages. As video number 18, we will discuss percentages and related topics like interest, compound interest, discounts, and investment returns in this video. Let us continue here. Now, let's look at the outline for this video. First topic we will discuss is percentages. Okay. Next topic we'll consider is some of the situation where percentages are used. Okay. We'll look at some of the situations where percentages might be used. Let's continue here. Then we'll look at simple interest. I call that interest shortly, but this is simple interest, then compound interest. Okay. Then we will discuss investment returns. Okay. These are all come from percentages. Okay. Then we'll do discounts. Okay. Let's continue. Okay. What's the percentage? It's also a fraction. Okay. Okay. How is it different from other fraction? This fraction is normalized with respect to 100, and that's kind of mathematical way to say. In simpler terms, it has implied denominator of 100. So it's a percentage has an implied denominator of 100. Okay, let's continue here. It's also a ratio, and sutra here is proportionality. So percentages are ratios, and for ratios we use the sutra proportionality. And ratio may be, let's see, look at some examples here. A common fraction, which might be proper fraction, improper fraction, or mixed fraction. It might be decimal fraction, which could be exact fraction or recurring fraction. Okay, let's continue. To clarify the concept, we will consider a few examples. Let us see. So first we know that it's a ratio, a fraction or a ratio, and denominator is implied to be 100, and the ratio could be a common fraction or decimal fraction. Okay, let us continue. Let's look at example here. Example, a 5-gram gold chain has 4 grams of gold. Okay? Okay. So we are interested in how much gold is as a percentages. Okay, let's continue here. Gold weight to chain weight ratio is gold is 4 gram and chain has a 5 gram. 4 divided by 5, and that is 0.8. I multiplied by 2 and the new also divided by 2, and this would let me divide by 10, which is easier. 4 times 2 is 8, and divide by 10, move the decimal 1 place to the left. So 4 divided by 5 is 0.8, and you can use this trick of multiplying and dividing by 2, and that would get you denominator of 10, which is easier to divide by. Okay, ratio is 0.8, and that is normalized with respect to 1. We did not do any normalization here. It's with respect to 1. 0.8. Ratios are always with respect to 1. Okay. So let's now we're going to multiply and divide by 100. Okay, so if you did that, ratio is 0.8 times 100 divided by 100. Okay, so we just did a by multiplication and division by 100. Okay, so that is equal to 80 divided by 100. A percentage have a implied denominator of 100. This is 100 denominator, and if I don't use that, I can place that symbol 80%. So that is 80%. 80% is percentage representation of 0.8. In an Excel spreadsheet, if you had number 0.8 and I say change format to percentages, that's what Excel would give you. Okay, Excel might give 80.00 instead. Okay, let us continue here. So what do we use percentages? Okay, some quantities are conveniently expressed as percentages instead of ratios. Some quantities have been represented by ratios, and some others are usually represented by percentages. Okay, let us continue here. Why do we use percentage? In some fields, we are more comfortable with percentages. Let's give an example. A bank pays an interest of 3% per annum on a certificate of deposit. That's a time deposit. Okay, it's money given to a bank which matures in a given time. Okay, let us continue. We could also say that its interest rate of 3 cents per $1. For every dollar, its interest rate of 3 cents, 0.03. And that is now normalized with respect to 1. It's a per $1. Okay. And when we do percentage, we say per 100. Let's continue here. Note both 0.03, that number, and 3%, that number, are 3 divided by 100. See that this had an implied denominator of 100, that's 3 100. And when we convert that to a fraction, common fraction, the 0.03 becomes 3 divided by 100. The two are equivalent. Okay, one is used almost exclusively in a banking field. Okay, we feel more comfortable in banking field expressing interest in terms of the percentages. Let's continue here. However, to compute earned interest, we use 3 divided by 100. We do not usually don't use that. That's good enough. That should be usable, and we definitely don't use that. Instead, we use that form, 3 divided by 100. Okay, interest earned at 3% per annum on $1,000 for in 1 year is $30. How do that? 1,000 times 3 divided by 100, okay, is $30. There's 100 here, 2 zeros, and 2 zero cancelled out here, and that become $30. Okay, let us continue. Okay, let's look at some more example of percentages. Okay, in a boys team of 15, a lone girl joins. Okay, so there were a team of 15 members, and they're all boys. A girl joins. Okay, let's continue. So female players divided by team players are 1 divided by 16. We had 15 players in team. Now one more joins. I have 16 now, and there's only one female. Okay, 1 divided by 16 is 0.0625. If you want to look at the other way, it's 1 over 4 times 1 over 4, 0.25 times 0.25, and which we know is by 1. The sutra by 1 more than 1 before gives me 0.0625. On left it's 2 times 3, right here. On right it's 5 times 5, 25. And I got extra 0 here because 2 digits after the decimal and 2 digits after the decimal multiplied. I need a 4 digits after the decimal here. 0.0625. 1 over 16 is, okay, that's the ratio here of female players to the team players. Okay. Now, when we normalize that with respect to 100, we get 1 over 16 and 0.0625 times 100, and that then we say it's a percentage. That is equal to 6.25%. Now, here is this number 0.0625 as ratio of female players to team players, and here is a in percentage, the same ratio is 6.25. That number seems to be more appealing here. In this case, 6.25% of the team consists of females is more appealing than 0.0625. Part of the team is female. Let's continue. Example, if 9 more boys join the team, total number of teams members are now 25. Okay, there 16 here, 9 more joins, 25. Now if I say male ratio of male players to the team players is 24 boys and total players 25, I multiply divided by 4, so that in the denominator I have a 100. Okay, so that give me 96 divided by 100. Okay, that is equal to 0.96. Then we multiply by 100, they give me 96%. To convert a ratio 0.96 to a percentage, we move the decimal place 2 places to the right. Okay. Okay. To convert a ratio of 0.96 to percentages, we move the decimal places 2 places to the right. We did the same thing here, 0.0625 right here. We decimal place was here and we move the 2 places to the right, 6.25%. So this is 6.25%. So similarly, to convert a percentage to a ratio, we will move decimal place 2 places to the right. 6.25% become 0.0625. It's just a common practice to use a zero. If a whole part is zero and the decimal fraction consists is only fractions only, uh, fraction of a whole number, then zero, it's usually we write a 0 point instead just a point. Okay, 6.25%. Here, same thing here. It's for answer is 0.296. We usually write 0.96, and now we move the decimal place to the right, become 96%. We move decimal place points to the left, become 0.96. Let's continue here. To convert a ratio to percentage, move decimal place 2 places to the right. Decimal point 2 places to the right. Let us continue. Let's continue with the next section here. Okay, in this section we'll discuss some situations of using percentages. Okay, so next section is simple interest. One after the compound interest, some investment returns, and some discounts. Okay, let's continue. Let's look at some situations using percentages. We will discuss a few common situations. It's very hard to enumerate every situation because we use percentages in almost every field. Let us continue here. Example, in a game of basketball, Tom shot 3 free throws when he got an opportunity to shoot 5. Question, how many free throws did Tom miss? Know anyone? What's the percentage of missed throws? What's the percentages of missed throws? Let's continue here. Number of throws Tom missed is 2. He got opportunity to shoot 5 and he shot 3. 5 minus 3 is a 2. Okay. Missed free throw percentages is, first of all, he missed 2 out of 5. That's the ratio of missed shots to all the free shots he got. Then we do a multiply and divide by 100. So that gave me a 40 in the numerator and 100 in the denominator. That's 40%. Okay. So also 2 divided by 5 is 0.4, and when we move the decimal place to 2 places to the right, we get a 40, and that means 2 divided by 5 is 40%. Okay? 2 divided by 5 is 40%. So he missed 2 shots out of 5, so he missed 40% of the shots. Let us continue here. Let's continue with situations here. Example, Linda fixes salad consisting of half greens, which is celery, broccoli, and spinach, 1/5 orange, carrots, and orange bell pepper, 1/10 red, which is red beans and beets, okay, and 2/10 of whites, which is all mushrooms. Okay, let's continue here. So what are the ratios of the colors now? Okay, we get half greens, 1/5 orange, 1/10 reds, and 2/10 white. So ratio is green to orange to red to white, which is orange is half, that's a half, greens is half, that's half, orange is 1/5, that's 1/5 here, Red is 1/10, that's 1/10 here, and white is 2/10, that's a 2/10 here. Okay? Now we're going to remove the numerators by multiplying each of these ratios portions by 10. Let's continue. So multiply half by 10, I got 5. Multiply 1/5 by 10 is 2. 1/10 by 10 is 1. And 2/10 by 10 is a 2. So green, orange, red, and white are in the ratio of 5 to 2 to 1 to 2. Let's continue here. So what percentage is green? Okay, it's a 5 out of 5 plus 2 plus 1 plus 2. 5 out of 10. Answer ratio is 5 divided by 5 plus 2 plus 1 plus 2, which is 5 divided by 2, 10, and which is 0.5. That's the ratio. And we're looking for percentages. Answer percentage is 0.5 times 100, which is 50%. And what we did is move decimal place 2 places to the right. So when you move 1 place to the right, it becomes 5. When you move 2 places to the right, it becomes 50. So 50%. Let us continue here. Okay. In a school of 800 students, 16 students called in sick on Monday. Okay. So total number of students is 800 and 16 were sick on Monday, did not skip the class. So what percentage of students attended the school on Monday? So some of the school students skipped the classes and rest of them attended the schools. Okay, let's continue. Percent of students, number of present students as were present were 800 were total, 16 were skipping classes, and 800 minus 16 is 784. So out of 800, 784 students were in the class that day. Percentage is 784 divided by 800. That's the ratio. We multiply that by 100 and call it percent. Okay, let's continue. That's 7.84 divided by 8. We divide both the numerator and the denominator by 100 here. So that's 7.84 divided by 8 times 100. That's a percentage. And that 7.84 divided by 8 is 0.98 times 100. So move the decimal place 2 places to the right. When we move 1 place to the right, become 9.8, and when we move second one more times, it becomes 98, okay, which is equal to 98%. So if we move the decimal, first we computed the ratio, then move decimal place to the right 2 places. Let's continue here. And what's the percentage of students that were absent? Present were 98%. The absent must be 2%. Let's see what we got. And 16 students for our 800 were missing, skipping classes. So there was 16 divided by 800, and that is 1 divided by 50. So if you divide by 8 here, it becomes 2 divided by 100. 8 divide the numerator and denominator by 8. That gets me 2 divided by 100, and 2 divided by 100 is 1 divided by 50, which is 0.02. That's the ratio. And percentage is 2%. What we do is move the decimal place from here, from 2 places to the right. When you move to 1 place, it becomes 0.2. When you move 2 places, it becomes 2.0. So percentage is number of students they attended school that day were 98, and number of students they percent, and number of students they skipped the classes that day were 2%. Okay, let us continue here. We looking at some more situations here. An arsenic in a water sample is 1 part in million. Okay, so when we looking for some trace amounts, we usually specify that as a part in a million, a part in a billion, in that kind of manner. Okay, let's continue. So arsenic water divided by water sample is 1 divided by 1 million, and which is 0.000001. Okay. and that is equal to, we multiply by, move decimal place 2 places to the right, right here, that becomes 0.300001%. Okay? So this is the ratio here, 1 divided by 1 million, which is 0.00001. And when move in percentage terms, we move the decimal place to the right 2 places and become 0.0001%. So arsenic in a water sample is a concentration of 0.0001%. Okay? And this 1 part in million that's used commonly looks lot more interesting than 0.0001%. Okay, let's continue. Example: in a school there are 30 boys and 50 girls. Okay, what's the ratio of boys to the girls? There are fewer boys. Ratio of boys to girls is 30 divided by 50, which is 0.6, and which is 60%. 30 divided by 50 is 0.6, and we move decimal place to the right 2 places, becomes 60%. Okay, let's continue here. But the ratio of girls to all students. Okay, so there are 50 girls in a class of 80. Okay? 50 divided by 50 plus 30 is 5 divided by 8, which is 0.625, and when moved decimal place to the right 2 places, becomes 62.5. Now, observations. To convert a ratio to a percentage, we multiply that by 100. In example, in a school with half boys and half girls, ratio of boys to girls is half divided by half, which is 1, and 1 is 100%. We move decimal place to the right by 2. Okay. To multiply by 100, we move decimal place to 2 places to the right. Okay. To convert percentage to a fraction, which is ratio, we divide by 100. An example: in a bag there are 40% black beads and the rest are red beads. What's the ratio of the red beads to all the beads? Black beads are 40% and red beads are 60%, and we're going to convert 60% to a ratio which is 0.6. What we did is move the decimal place to the left by 2. From 60 is 60.0, so we move decimal place to 1 place to the left, becomes 6. One more place becomes 0.6, and we call it 0.6. Okay. Let us continue here. Exercises, and all the exercises are from James T. Glover's book. 2. Compute 4% of $45, 110% of 650 centimeters, 15% of 80 centimeters, 75% of 24 inches, and so on. Okay. Let's continue with the next section. Okay. We already discussed percentages and some situation using percentages. And in this section, we will discuss about simple interest, generally called interest. Okay. Then we will have section on a compound interest, investment returns, and discounts. Let's continue here. Simple interest. What's interest anyway? It's in simplest term, it is like a rent on money. Okay. In financial circles, it might be called time value of money. Okay. Someone lends money and he expects a return on it, and it's called interest. The return on the lent money is interest. Okay. Let's continue here. So how to compute interest? First thing is we know what interest is, then we have to compute interest, and let's see how to compute. It's just like, again, computing a rent on a property. Okay. If someone leases an apartment at $300 a month for a year, then his rent would be $300 a month, and for the entire lease time it will be $3,600. Okay. So it's just like same thing, that we will rent or lend money at interest, which is a return just like rent. Okay. Let's continue here, and here's the formula we will use to compute. Simple interest is units of money times interest rate times period. Units of money is like a property. And interest rate is like rent on a property, and period is number of terms, like number of months, number of years. Okay, let's continue here. So we would need a how much money is involved, and what's the interest rate agreed on, and what's the number of periods the interest need to be paid over. Okay, let's continue. Paid for. What's units of money in this question? Is we call it principal value sometimes. Principal or principal value. It's the amount in a currency borrowed by one party and lent to the other party in a transaction. And we'll have some examples here. So if $100 involved in a $100 lent at interest of 6% per year for 3 years. Okay, so here all three terms are stated here. Here's the units of currency, $100. Here's the interest rate, 6% a year. Here's the number of years. So it's 6% per year. So we have 3 years here. Okay, that's the number of periods is 3. And like $45.34 in a savings account. So that is this amount is the principal. Let's continue here. Or another example is $1,000 in a $1,000 certificate deposit. Certificate deposit is time deposit, and I believe in India they call it fixed deposit. Okay, $1,000 would be a principal in a $1,000 CD. Let us continue. Same section. I say interest. It's a simple interest talking about. It's the same formula. I just repeat: units of money times interest rate times periods. Okay. What's the second term? It's agreed upon the return, also called rent in the property situation, on the borrowed or lent money. In rental property, it will be rent, not a lent money. It's stated in percent per period. Okay. Examples would be 3% per year, like okay, and another would be 1% per month, and maybe 6% per year, and so on. Okay, so these are just examples here. Let's continue. What's the period? This next we get this one, period, which is number of the terms. It's number of time units of the transaction term. So in a rental property, it will be in a year worth of lease 12 months. Okay, so in a certificate deposit for 3 years, it will be 3 years. Okay? And okay, in 30-day notice, it will be 30 days. 30 days is the period. So in 3-year time deposit, its period is 3 years. Okay? In 10 years, U.S. Treasury period is 10 years. So Treasury matures in 10 years. In a 30-day note, its period is 30 days. Interest is again principal value. Units of money is called principal or principal value. And interest is called rate, and the period is called N. So it's a principal value RP sometimes, RPV times rate times N. That's how we compute a simple interest. Simple interest is principal value times rate times N. Rate is stated as percent per term, and N is number of those terms. Okay. And I'm looking for example. I'm getting example from a book, Figuring. Figuring is by Shakuntala Devi. Okay. Let's continue here. Example. What's the interest on $326 earning at the rate of 6% per year for a period of 60 days? Okay. This is my principal value. This is my rate. This is the 60 days is the number of days involved, and interest is stated as per year. So 60 days would be 1/6 of a year. Okay. Let's continue here. We'll make some assumptions here. Assume 30 days in a month, 12 months in a year, and 360 days in a year. We also did that same thing, assumptions in my 4th grade when we learned the interest. Let's continue here. Interest is 326. So many are the principal, and this is the 6% is 6 divided by 100. Remember that when the percentage we say that it has the implied denominator of 100. That's my implied denominator of 100, which in this expression I explicitly state that it's 100 is the denominator. That which was implied was I have stated that explicitly here. And here the number of terms here, number of terms. It's a 60 is the day and 360 is the whole term. So 60 divided by 360 is the number involved here in the example here. Let's continue here. So that's equal to 326 times 6 times 60. I'm just trying to multiply first horizontally, first the numerators, 6, and then denominator, 100 times 360. Okay, let's continue here. Now here is 360 here, 6 times 60, and 360 in the denominator. So we would cancel them out. We'll divide both the numerator and denominator by 360. Okay, let's continue here. That gave me 326 times 1 divided by 100. When you extract out a factor of 360 from here, it leaves a 1. Okay, and when you extract out a factor of 360 from the denominator, leaving me 100. Okay, and that is equal to $3.26. So what happened is, in this example, my number of days is 60, interest rate is 6% per year, then interest is for 60 days. We just take this number $326 and move the decimal place to the 2 places to the left. So we just did that. So it become 326 cents. When you take it $326 and try to compute interest at rate of 6% per year for 60 days, it is 326 cents. And that comes from 1 over 100. $1, 1/100th of a dollar is a 1 cent. Okay, so that is $3.26. So for this example, it's simple because 360 here in the numerator and 360 in the denominator cancel out. Okay, let's continue. As numerator and denominator both have a common factor of 360. Observations. Okay. So we just use this observation here, 6 times 60 divided by 100 times 360, that was involved in the previous calculations. Okay? So, and that 360 divided by 100 times 360, and 360 is a common factor of the numerator and denominator of this fraction or ratio. Okay, okay, let's see. So cross out 360 in the numerator I got 1, in denominator I have 100. Okay, so that's a 1 divided by 100, and which is 0.01, and that means when we multiply this number by something else, that's something else, we move the decimal place 2 places to the right. Okay, let's continue here. For interest rate at 6% for a period of 6 months, just move the decimal place to the left by 2 places. Okay, so for interest at the rate of 6% for a period of 6 months, just move the decimal place to the left by 2 because of this simplification here. Let's just continue here. Can we use same results in other cases? Now, this was a special case, and we were able to cancel out the 360 in the numerator and 360 in the denominator. Okay? You can sure try and often succeed. Okay? The following slide includes more examples from the same book where we use a different number of days or different percentages. Okay? Let's continue. Example. Compute interest of $398 at 6% per year. We still have same rate, but we have 70 days now. Okay? We know that for 60 days, interest rate would be $3.98. Move the decimal place to the 2 points to the left. So just did that. Our $398 become 398 cents, which is $3.98. Okay, now 60 days interest we are computing. Now 10 days we need to compute. Okay? Interest for 10 days is $0.66, 66 cents. Okay, it's 0.66 cents. I just did 1/6 of that and did rounding. Okay, so 398, 1/6 of that is 0.66. Okay, I did some rounding. I'm trying to keep it 2 decimal places because US currency is the smallest denomination is 1 cent, which is 0.01. Okay. Interest for 70 days is, I'm going to add these two terms, 60 days, 398, $3.98, and for 10 days is 66 cents. So we add $3.98 to 66 cents and I have a result of $4.64. So it is a for 60 days was $3.98 interest, and for 70 days interest is $4.64. Let's continue here. Interest on $456. So we have a four. Another example is 6%. Now we have 66 days. So still keep the 6% here. Okay. So for 60 days it's $4.56. Okay. For 10 days, 6 days is 46 cents because it's I'm taking tenth of this number here. Okay. 66 days interest is that number $4.56 plus 46 cents is $5.02. Okay. Let's continue here. Continue and see, make some observations from the previous discussions and examples. Let's continue here. How do we handle interest rates? Different interest rates. We in the examples I covered, interest rate was always fixed at 6% per year. So let's see if we had a different interest rate. How do we do that? Okay. In VM, we try to use pre-solved results, which are more sutras or observations. As such, we can represent other interest rates in 6% in terms of 6% per year. Okay, so if the interest rate is not 6% per year, and let me show you how we do that. So give some examples. 3% per year would be half of the rate, 6% rate, and 2% of per year would be one third of the 6% per year rate. 1% per year would be 1/6 of the. So we compute at 6% per year, then we divide by 6. Okay. Okay, and 4% would be 3%, which is half, plus 1/6, 1% a year. Okay. And 5% per year, it would be 3% per year plus 2% per year. Okay. And 7% per year would be 6% per year plus 1% per year. Okay. And 8% per year would be 6% per year plus 2% per year. Okay, let's continue. You can We're not trying to make it complicated here in Vedic math. We're trying to see maybe it's simpler somehow because we have pre-solved result for 6% and so maybe per year, and we already know, and 60 days it's say uh, $1 earns a 1 cent of interest. Okay, so in 60 days at 6% per year, $1 earns 1 cent of interest. Okay, but if you prefer, you can apply the formula directly. Okay, so if this one seemed a little too cumbersome, okay, and you can apply the formula directly if you prefer. Okay, so these are just ways to use the pre-solved results of that. We know 6% per year for 60 days is 1 cent for every dollar. Okay, let's continue. Now we look at next section here, and next section is compound interest. We have already discussed percentages and some examples, and also we'll see simple interest, and we'll see a compound interest, and so what that is. Okay, investment returns and discounts will be discussed later. Let us discuss interest. What is that? What's compound interest? In this case, interest earned on principal in one term is added, which is called compounded, to the principal for the next term. Okay? In next term, principal is a higher value than it was in the previous term. Okay, let's continue. How is that different from simple interest? In simple interest, a borrower pays the interest at the end of the term, and in compound interest, borrower rolls over the compounds, which is compound interest earned into principal for next term. Term here means that term of the stated interest rate, like 6% per year, 2% per month extra. In 2% per month would be the term would be 1 month, and 6% per year would be term would be 1 year. Okay, let's continue. Examples. Treasury bond paid interest periodically, so it has simple interest situation, and it does not compound. It does not roll over the interest into the principal, and it's a simple interest situation. Okay. As saving bond, double savings bond roll the interest into principal. That's a compound interest case. Okay. Let's continue. A time deposit usually roll the interest into principal. Okay, and in USA they call it certificate deposits, and in India, I believe they call them fixed deposits, and uh, most some other countries might call them by different name. I'm going to look at example again from the same book, figuring. Okay, a $3,000 is lent at 4% per year interest rate, with interest paid and compounded quarterly. Okay? So how much interest does the lender earn in 1 year? Okay. So principal value is $3,000. We just got from here. Okay. Interest rate at first quarter is one. It's a 4% per year, and it's which would be equivalent to 1% per quarter. Okay. So 1% of $3,000 is $30. Okay. Just move the decimal place to the left by 2. Okay. Now principal value is at the end of first quarter is $3,000 principal and $30 is the interest. We add the interest to the principal, and now new principal value is $3,000.30. Okay. Interest at second quarter would be at the end of for second quarter would be 1% of $3,030. Okay, which would be 3,030 cents. Okay, it's 1% per quarter. So that would be $30.30. Okay, now new PV would be $3,060.30. Okay, 3060 decimal point 30. Okay, so that's new PV going forward for the into third quarter. Interest at the end of third quarter would be 1% of that. Okay, $30.60. I just rounded that up, and this 3 here did not show up in the interest rate here. In USA, the smallest unit of currency is 1 cent, which is 100th of a dollar. Okay, let's continue here. New PV is I add $30.60 to 3,060.30, which comes out to $3,090.90. Okay, let's continue here. Interest at the end of fourth quarter would be on this is say now this is the principal value going to fourth quarter, and interest one is 1% of that, which will be $30.90, 91 cents, which again we rounded them up. Okay, this was a 9/10 of a cent become a 1 cent, and that's $30.91. We just rounding it. Okay, so new principal value is add these two numbers together 3090.90 plus $30.91. I get a 3121.81. So we have $3,121.81. This is the final value, and some folks might call it instead of principal value, call it final value FV. Okay. Total interest earned is this is the money was lent, and this is the money was paid out to pay off the loan. So 3121 decimal 81 minus 3,000 is $121.81. If you add this number together, instead of interest $30 to $30.30, then add $30.60, $30.91, that should also come up to $121.81. Okay, let's make some observations here. Question: did you notice we kept computing new principal value after interest was paid out? Yes, we did, and that is the compounding. So what we were doing is we compounding the interest paid into the new principal. We're adding that interest, rolling the interest paid into the principal, and that's what compounding the principal here. Okay. Question: is there another term for updated PV? Yeah, in some circles it's a final value. So instead of at least the last value when paid out might be called final value. In the intermediate, updated principal value is still updated principal value. Okay. And the final value paid out is may be called final values in some circles. Let's see where the compound interest is used. Example: In USA, most accounts compound daily, okay, and banks usually quote the interest in terms of annual percentage yield, known as by APY. So, okay, in USA, most banks compound daily, and on a savings account, interest is quoted as annual percentage yield, also called by APY. Let's continue here. Installment payments. Banks use compound interest to compute periodic payments of loans like auto loans and home mortgage loans, etc. And that's usually true in USA because I'm not familiar with the other countries, so I have no idea how they do it. There might be some exception. Islam does not allow payment or receipt of interest income, and some banks make alternate arrangement to serve that segment of population. And there are some banks in New York they do that and have some different arrangements for the mortgage loans, okay? At least for mortgage loans. Okay? So banks use compound interest to compute periodic payments of auto loans, mortgage loans, and other term loans. Okay? Let's continue here. Investment. If an investment grows the annualized rate of 10% a year, at that rate, $1,000 will grow in 3 years to $1,331. Okay, that's with the application of the compound interest. So $1,000 plus $100 for the first year, 110, 10% of this running sum here. Okay, for the second year and third year, 10% of the running sum of first three terms is 121. It's a 1331, and when we add, okay, so this is the final value 1331, and the interest is $331. 1,000 was the principal, original principal. Okay, let's continue. Let's do some exercises for interest computations. Okay. Question: what's the first exercise is what's the simple interest on PV is $10,000. Rate is 5% per year, and for 2 years. Period is 2 years. We say 5% per year and 2 years. So number of terms is 2. Okay, let's continue here. Next question. Compute compound interest on principal value of $500. Rate is 10% per year for 4 years. Okay, when interest is compounded yearly. So at the end of the year, interest rolls into the principal. Interest is compounded to the principal. Okay, let's continue here. Problem 3. What simple interest of principal value is? What's the simple interest on principal value of $600? Rate is 1% per quarter, and a period is 1 year, which is 4 quarters. 1 year is 4 quarters. Okay. Let's just continue here. Simple interest, not compounding. Simple. Challenging problem. Sam borrows $1,000 to return $2,000 at the end of 7 years. What's the annualized interest rate on Sam's transaction? Okay. Here it's a compounding interest with a little twist, okay, which is it doesn't tell you the rate. You have to compute that. It tells you what the final value is and what the initial value is. Principal value is $1,000. Final value is $2,000. Number of years is 7. Interest rate is not given. Okay, and okay, let's continue here. Let's go into next section here. Okay, in this section, what we discuss, we are going to discuss compound interest. We discussed already. We're going to discuss some investment returns now, okay, which is the same thing, similar to compound interest. Investment returns use compound interest. Okay, let's continue here, and then we'll discuss some discounts. Okay, we'll discuss some returns for the investments. Investment returns. Okay, what's investment return? Okay, in simple terms, it's like interest. Okay, so if it's like interest, why it is different? What's different between interest and investment return? Okay. Answer. Interest earned at a bank is always positive. In US, bank deposits are insured to a limit. There might be some exceptions in different countries, but here in US, it's always positive, at least so far. There's no such guarantee in investments. Okay, an investment can go down just like it can go up. Yeah, in some parts of the world, that investment might be just like a lending money and interest. So in that case, it would be always positive. Okay, or if only investment a person is interested in is investing money at a bank, then it is always positive. Let's continue. Investments can have both positive and negative returns. I usually mean that you try. By investment, I mean you are going to invest money in a stock market or some other markets. Let's continue. Give me example. He get you example here. Tom invests $1,000 in a stock. Okay. First month it gains 10%, and in second month it loses 10%. And what is the value of investment at the end of 2 months? So here's an example where we make a positive return on a first month and negative return in the second month. Okay, let's continue here. So it's like principal. I say it's like a compound interest here. Initial principal is which principal value $1,000. Return in first month, which is like interest, is $1,000 times 10% is $100. 10% of $1,000 is $100. Okay, move the decimal place to the left by 1. Okay. New principal for going into second month is $1,000 first principal plus this interest is $1,100, just like the compound interest example. Okay. Let's return in second month is negative 10%, loses, minus 10 divided by 100. 10% is minus 10 divided by 100, and negative is loss. So 1100 times negative 10 divided by 100 is negative $110. Okay, final principal, which is final value. Initial principal was 1,000. Final value is 1100 was at the end of the first month, and we lost $110. So 1100 minus 110 is $990. Okay, so when I talk about investment, that's the kind of investment I'm referring to. Okay, it's not something invested at a fixed rate. Okay, let's continue here. That's like computing compound interest. So we just did the initial principal, then we have return, just like interest. That is similar to interest in a compound interest case, and we then we added that interest, compounded that into the principal, get a new principal here. Then on the new principal, we lost some money, and this is my return, negative return on second month, and final principal, final value is the principal at the going into second month, and this loss here, 1100 minus 110, 920, and that is like a computing compound interest. Okay, I will leave with just that much exposure to investments, and it's just to show that investments are like a compound interest. Okay, when we compute return, it's like interest, and when we add the returns into the principal for the next term, it's become like a compound interest. Okay, let us continue. Let's go to next section now. Next section is about discount. We already discussed the first sections here. Discounts. Okay. What's discount? It's a negative interest. Okay. It's like a negative interest. Okay, let's continue. How's that? In case of interest, we add earned interest to compute the final value. In case of discount, we subtract discount to arrive at a final value. Okay, let us continue here. A merchant is discounting his shoes by 20%. Thus, for shoe priced at $29, merchant will charge you how much? So he would consider, first of all, $20 minus 20% of $29. Okay, was 20% $29? Okay, 10% is $2.90, and 20% must be $5.80. So we subtract $5.80 from $29. We got it, $23.20. Okay, so we two steps. First, we compute the discount, and then we subtract the discount from the principal. Looking for another example from the same book, figuring. Okay, discount $40 by 30%. Okay, first the discount is 30% of what that was say of $400. That's the principal or cost. Stated price is $120. Okay, and discount value is $400 minus 120, which is $280. Okay, continue. Shortcut calculation is 30% discount means discount value is 70%. 100 minus 30% is 70%. Discount is 30%. Discount value is 70%. 30 plus 70 is 100. Discount value of 400 is 400 times 70%, which is $280. 70% of $400 is $280. Let's continue here. Example. Okay, let's look at this example here. This 400 here, this is 70 divided by 100. 70% is 70 implied denominator of 100. So let's state that denominator explicitly, which becomes 70 divided by 100. 100 and 400 have a common factor of 100. So that means, so 100 divided by 100, 100 denominator here and 100 factor in 400 cancel out, leave 4 times 70, which is $280. Let's continue here. Compute discounted value from price for 30% discount of a sewing machine listed at $185.60. A sewing machine listed at $185.60 is discounted as 30%, and how much is the customer is going to pay. Okay? So 30% discount means 70% discount value. $185.60 times 70% is 0.7 is equal to of 185.60, okay, which is equal to $129.920. We just use the 92 cents. Okay? 129.92, $129.92. Let's continue here. Okay? That's that one. Because third place decimal doesn't matter. Currency have only 1 cent, which is smallest denomination in the currency is 1 cent, which is 100th of a dollar. Let's come on to some. Let's continue with the example here. What's the discount of 32.5% on $280? Okay, so if that's not straightforward, 30%, 20% discount, or 25%. So let's have a discount of 32.5%. Let's see how we do that. So 25% is of $280 is $70. Okay, 1/4. 25% is 25 divided by 100, which is 1/4. Okay, which is of $280. So we got 7.5% left. Okay, 5% is $14. Okay? 5% is 1/5 of $7, $14. 1/5 of the one in here. Okay. Okay, then 2.5% is half of this one is $7, half of previous line. So we just add them up. 32.5% discount is $7 plus $14 plus $7, $91. Okay, so $91 is discount, and yeah, that's what computer discount as. Okay, what's discount of at 67.5% on $460? Wow, we got discount of large discount 67.5% on $460. Okay, that's we're computing in discount, not the value. Okay, final discount value. 50% of the $460 is $230, half of. 50% is 1/2. Okay, 10% is of that is $46, which is 1/5 of this one. Okay, 230 divided by 5 is $46. Okay, so how much we left? 60. We already got. We got 7.5 left. Okay, 5% is half of this line, $23. 2.5% is half of that previous line, 11.50. Okay? And discount at 67.5% is equal to 230 plus 46 plus 23 plus 1150 is $310.50. Okay, let us continue here. Okay, so now you see that if it's not straightforward multiplication, you can split do divide and conquer. We use the rule divide and conquer sutra here. 32.5 is equal to 25 plus 5 plus 2.5 plus is equal to 32.5. 67.5 is equal to 50 plus 10 plus 5, okay, and plus 2.5, okay. Okay, so, and then you can do 50 plus 12.5 and plus 5, because 12.5% is 1/4 of this line, and okay. So discount is $310.50. But we did use it, divide and conquer. Okay? That's some observations here. Instead of first compute discount followed by subtraction to compute discounted price, we do that in one step. We can do that in one step. Okay? When discount computation is not easy, we use divide and conquer, where we divide the discount into easily computable components followed by an addition. Okay? When discount computation is not easy, we use divide and conquer, where we divide the discount into easily computable components followed by an addition. Let us continue here. We divide the following by, we have a divide followed by a combine. Okay, let's continue here. Let's do some exercise here. What's discount at 15% off $275? Okay. So you can do in two steps, 10% plus 5%. Okay. What's the checkout price of a merchandise listed at 29% and discounted by a third? Okay. A pair of shoes are listed at $37.50. On Wednesday, merchant discounts everything at 15%. What's the checkout price of that pair of shoes? Okay, on Wednesday. Okay? On Wednesday, it's 15% off. A supermarket is discounting melons by a fourth. How much would a customer pay for melons priced at $13? A fourth is 25%. Okay? Yeah, one third is 33 and a third percent. Okay? Let's continue here. Recap here. Okay? We started with percentages. We use percentages concepts to compute interest. Extended that to compute compound interest. Introduce the concept of final value. Use those concepts to arrive at investment returns. Use the same concepts to compute discounts. Percentages are used in too many fields to enumerate, and this video gives you a taste of the concept, and you should find the idea useful in numerous fields. So it's the percentages are used in too many fields to enumerate, and I don't know, I'm not aware of all the fields that used in. Okay, and this video gives you a taste of the concept, and you should find the ideas useful in numerous fields. Okay, let us continue here. Let's look at references here. Okay. First reference is Vedic Math Teacher's Manual, Volume 1. This is Elementary Teacher's Volume, and it's by Ken Williams, and you can find it at vedicmaths.org. PDF form is available for free, and print form you can purchase. Let's continue here. Second reference listed is the common reference, that's the primary reference, Vedic Mathematics by Bharti Krishna Tirtha ji, and that is the primary reference on the Vedic math. Tirtha ji is a founder of the Vedic math. Let us continue. Now here is Discovery Vedic Math by Ken Williams. It's a most complete, authoritative, and consistent notations, and this book is organized by sutras. Let's continue here. Vedic Math for Schools in 3 volumes by James T. Glover. Mr. Glover used these books in his school. They're very easy to read, very complete, not as complete as Williams' book is, and contains significant geometry which I have not covered at all. Let's continue here. And Figuring by Skuntala Devi. I used some of the exercises from this Glover's book, and I used some of the examples from this book Figuring. Let us continue here.